So just going to go over everything that we went over the last few days, starting with our parent function of our quadratic, which is y is equal to x squared. So remember, our parent function is like the most basic version of um, that function, that equation we're graphing. It passing through the origin. There's nothing that's being done to it as far as on the additional, multiplying, addition, subtraction. In this case, it's just that x squared, which is our quadratic equation. And we are looking at the parent function. So remember, when we're graphing these, I'm going to want you to create a table. And for our vertex, for a quadratic, remember, we want to first figure out where our vertex is. And when it's our parent function, that vertex is at the origin of 0, 0. Then you're going to pick one point that is directly above it, so 1, one point that's directly below it, 2, or negative 1, I'm sorry. And then you're going to pick another point that's directly above that previous one, so 2, and a point directly below that previous one, so negative 2. I put them the same colors as we talked about. This graph is going to be symmetrical, so the blue x values are going to actually end up having the same value of y, and same with the red. Once you figure out which x values you're going to plug in, then you're going to go ahead and actually substitute it into the equation. So let me go ahead and adjust this so I have some room. So I'm going to plug in what y is equal to, and x is 1. So y is equal to x squared. Well, x is equal to 1. So y is then equal to 1 squared, or y is then equal to 1. So when x is 1, y is 1 as well. So it's generating that point 1, 1. Remember, all of these points are going to fall on the equation. So that's why we're saying, okay, we can pick our x value to generate, well, where is y going to be at that point? And that allows us to then plot these points to draw our graph. So when x is equal to negative 1, as I said, I put them in the same color because you're going to see, well, now y is equal to negative 1 squared, and negative 1 times negative 1 is also a positive 1. So since it's being squared, it's going to create this symmetrical parabola, which once you get the hang of it, once you graph one side of this vertex, we can use that to generate the points of the other. So then for when x is equal to 2, we now have y is equal to x squared, or y is equal to 2 squared, or y is equal to 4. So now it generates a point of 2, 4. And when x is equal to negative 2, we're going to see it's giving us the exact same value. So it's negative 2 squared, or y is equal to also positive 4. So this generates all of these ordered pairs of negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. So we know that this graph, y equals x squared, passes through all these points. So I'm going to go ahead and plot them. We have 0, 0, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. And it's a U-shaped graph, so it's going to then look like this. It's a little bit harder to draw this with my pad, and that will be our graph. So remember some things that we talked about. This vertex, from here, we can find out what our axis of symmetry is, so where our graph is cut directly in half, and that's our x value. And we find a max or a min, and our min or our max is determined based on how it's opening. So when it's opening up, we have a min value. When it's opening down, we have a max value, and that is going to be our y value of our vertex. Let me just erase that. Of our vertex. And then our axis of symmetry, so where our graph gets cut in half, is the x value of our vertex. All right, so when we're going to start graphing some of these other problems in just a moment, we're going to be comparing them, in the beginning at least, to our parent function, because we're going to first learn how to graph, or we did learn how to graph in vertex form, and that was just sliding our graph around. All right, so let's go ahead and do another problem, and this one is going to be in vertex form. All right, so remember, whenever we're getting a new graph, for now, in the first couple examples, we're always going to be comparing it back to our parent function and that vertex, 0, 0. And we're going to be saying, okay, how are we adjusting, or how is this parent function moving? Because right now we are in, remember, what's called vertex form. Actually, let me write this over here on this side. This is in vertex form. And in vertex form, we see our equation as y is equal to a times x minus h squared plus k. So this is one of the ways that it can be written. Remember, this h is telling us our horizontal shift, so how we're moving horizontally, and our k is telling us our vertical shift. Our A is telling us whether we're reflecting or whether we're being stretched or compressed. But in order for us to identify our vertex, remember, for right now, that's the point that we need to plot first, because without the vertex, we're not going to know where that graph stops and turns around. So we're always trying to figure out where is the vertex, and then we're going to create our table. So we're focusing on this H and this K because that's telling us how our vertex is translating or how it's sliding, how we're moving from that point 0, 0. So as we discussed in class, this plus 4 is included with that x. It's inside the parentheses, so it's directly affecting the x. And we know that when we're directly affecting that x, we're moving along that x-axis. So we're either going to be moving left or we're going to be moving right. And since this formula is minus that number, that's what the formula really is saying, that means we're taking the opposite of that number. So when we see plus 4, we can also ask ourselves, well, what number will get us back to 0? Well, negative 4 will. So that means that this vertex needs to move to negative 4, which means that we're moving to the left 4 units. So my vertex originally with my parent function 0, 0. Now with this one, since I know that this is affecting our x directly and it's telling us we're moving to the left 4, well, we can represent that as a negative 4 for x. Now the number outside, this is affecting at the end our y value, because if you think about it, we learned y is equal to x as a linear graph. And this, when nothing's being added or subtracted to it, we know that we're passing through its origin and it's proportional. Well, as we start saying x plus 3, we know that our y-intercept now is 0, 3. So you see our y-intercept moved 3 units up because we're adding 3 after, all the way at the end at the x. So here we're subtracting this 5, which is that k, which is moving us, telling us how we're moving vertically. And since it's plus k, we're going with the sign. If the sign's negative, that means the value's negative, just like it was with our linear graph. So this is telling us that we're moving down 5. And to represent down 5 algebraically, that means that it is minus 5. So our vertex is now at the point of negative 4, negative 5. And now it's exactly what we just did with our parent function. We put that vertex directly in the middle, and then we're going to pick an x value that's directly above it, so just add 1 to it, so negative 3, subtract 1 to it, so negative 5, and then we're going to add 1 to this one, so negative 2, and subtract 1, so negative 6. So I'm creating this symmetrical graph. So now when I plug in, y is equal to x plus 4 squared minus 5. Well, now I'm going to plug in negative 3, so x is equal to negative 3. So y is equal to negative 3 plus 4 squared minus 5. Y is equal to 1 squared minus 5. And you see these numbers are always going to come back to that 1 and that 2 after we plug it in. So y is then equal to 1 minus 5, which then y is equal to negative 4. So when x is negative 3, y is negative 4. Now I'm going to plug in when x is negative 2. So now we have y is equal to negative 2 plus 4 squared minus 5. Well, y is equal to 2 squared minus 5. Y is equal to 4 minus 5. Or y is equal to negative 1. All right. I'm going to zoom this out just so this way we can do the other values. So here we have x is equal to negative 5. So y is then equal to negative 5 plus 4 squared minus 5. Y is equal to now negative 1 squared minus 5. Y is equal to 1 minus 5. So you see it comes right back to here. Because if we have 1 squared or negative 1 squared, it's going to give us the same value. So because it's squared, it's going to make it symmetrical. So y is then equal to negative 4. And because we see that, I'm not going to do the negative 6 in. I'm just going to know that it's also going to be negative 1. And then this generates the points of negative 6, negative 1, negative 5, negative 4, negative 4, negative 5, negative 3, negative 4, and negative 2, negative 1. And now we're just going to go ahead and graph these points of negative 4, negative 5, negative 3, negative 4, negative 5, negative 4, negative 2, negative 1, and -6, -1. So there's our points, and then I'll draw my U shape going through it. And in this case, our minimum value would be that -5 because our graph is facing up, and it is our y value. And our axis of symmetry will be x is equal to -4. That would be the graph that we could plot through it that would make this symmetrical. All right, so that is in vertex form. And now there's just one more example that we're going to go through when it is in standard form. All right, so now the other types of problems that we learned is y is equal to x squared minus 6x plus 5. So something in this form. And this is in our standard form. Let me zoom out a little bit. So this is in our standard form. Standard form is written as y is equal to ax squared plus bx plus c. So since we have both an x squared and an x within our same problem, we can't just look and say, okay, it's sliding 6 to the left, because in vertex form, we only had that one x that we saw. And it was just something being raised to the power of 2. So in this case, when we have both a power of 2 and that linear term x, you can do this a few different ways, and you will learn different methods later on. But right now, we're only going to learn a specific method. And so we can't talk about it being slid or anything like that, but we can still find its vertex. And to find its vertex, we're going to use the formula of -b over 2a. That generates the x value of our vertex. And once we find out that x value, we then plug it in, and then that will give us our y value of our vertex. So once we plug it in, it's going to give us what our y value is equal to, and then there we have a vertex. So we can't, in this one, it's not actually just looking at it and seeing how's it slide, it's plugging it into this formula and then generating it. So from this case, the a is always the number in front of our x squared. So our a in this case is equal to 1, because when there's no number written, it's understood to be 1. Our b is always a number in front of the x, so it's -6. And our c is the constant 5. So in this case, if I want to find our vertex, the first thing we need to do is plug it into -b over 2a. Well, it's now going to be negative of -6 over 2 times 1. So now this is going to be 6 over 2, which is 3. So I know my vertex now has the x value of 3. So think back of all the other problems that we just did. When we knew what x was, we can figure out y by simply plugging it in. So we have x is equal to 3. So now we're going to say, okay, well, what is y when x is 3? So we're going to plug it in. We have x squared minus 6x plus 5. So we have 3 squared minus 6 times 3 plus 5. Well, 3 squared is 9. -6 times 3 is -18 plus 5. So now this gives me -9 plus 5, or y is equal to -4. So now we have the vertex of 3, -4. So remember, our goal is always to figure out what is our vertex. That's what we need in order to graph it. When it's in vertex form, we can look at it and talk about the way our graph moved and slid, and that generated our vertex point. When it's in standard form, we can plug it into this formula, -b over 2a, to figure out our x. And once we know x, we plug it in to figure out y, and now we know our vertex. Now we know where our graph stops and turns around, and now we can start building our table. So we know that's where our vertex, we know that's the point that our graph is going to stop and turn around. So I'm going to pick a point greater than it and a point less than it. And then I'm going to pick another point greater and another point less. And now it's back to exactly what we're just doing. I'm just going to erase all this so that we have room. Now it's going back to what we were just doing. Previously, even when we were talking about it sliding, once we figured out what our vertex was, well, then we need to plug things in. So when x is equal to 4, we're now going to plug it in of y is equal to x squared minus 6x plus 5. So y is equal to 4 squared minus 6 times 4. Get in the habit of putting when you're substituting in parentheses, because when it's negative, if you don't put it in parentheses, you might make a mistake. So y is equal to 16 minus 24 plus 5. Y is equal to -8 plus 5, or y is equal to -3. And since we know it's symmetrical, I also know 2 is going to give me -3. You can plug it in, though, to verify if you would like. But for interest of time with this video, I'm not going to. So now we have x is equal to 5. So y is equal to 5 squared minus 6 times 5 plus 5. So y is then equal to 25 minus 30 plus 5. So y is equal to -5 plus 5, or y is equal to 0. And if that's 0, that means that this one is also 0 as well. All right, so now I'm just going to go ahead and write these points out. We have 5, 0. We have 4, -3. We have 3, -4. We have 2, -3. And we have 1, 0. Now, these two, I'm going to star these. These 2 points are going to be something that are very important that we're going to talk about and something that you guys will actually be solving for all the time. All right, but now we're just going to go ahead and plot these. We have 3, -4. So here's 3, -4. Then we have 4, -3, and 2, -3. We have 5, 0, and we have 1, 0. And now we're going to go ahead and draw our graph. And there is our graph. All right, so when it's in vertex form, we find our vertex by the way it's sliding. When it's in standard form, we find it by using this formula, but our step 1, no matter what, is finding the vertex, and then from there we build our table.